is in startup.
And there it is. Falcon Heavy is now in startup, and those flight computers are in control of the count. So we're now just waiting on the final go, no-go from the launch director for today's mission.
The launch director is go for launch.
And great news there. The launch director has given the final go for today's mission. So let's sit back and watch as Falcon Heavy takes the Nancy Grace Roman Space Telescope to space.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon Heavy and go Roman Space Telescope.
And liftoff of NASA's Roman Space Telescope on a mission to revolutionize our understanding of the universe.
All M1D chamber pressures are nominal.
Falcon Heavy has cleared the tower and is on its way to space.
Looks like a beautiful launch so far, Steve. Great shot there from on top of the rocket, looking down, and then now tracking up, looking at those 27 Merlin engines, lifting the Falcon Heavy and Roman Space Telescope off into space.
Falcon Heavy soaring.
Power and telemetry nominal.
Falcon Heavy soaring into the Florida sky. We are 53 seconds into this flight. Rocket will be heading into max Q.
Falcon 9 is supersonic.
Picking up speed and altitude very quickly. Engines will throttle down slightly to reduce the mechanical pressure and the mechanical stress on the rocket.
Max Q.
And we heard that call out for max Q, which is the point of maximum aerodynamic pressure as the rocket is ascending. Now, coming up in just under a minute from now, we're going to have a large series of events happening back of those two boosters. Followed by that, we will then have MECO of the main core, and then stage separation of that, as well as second engine start one following that. Now, those two boosters will be heading back to Florida today. They'll be doing boost back burns to put them on trajectories back towards call out for BECO in just about 13 seconds from now.
Side booster separation confirmed.
And there we saw stage separation, and you can actually see the view from the main core on the left, and then the two side cores on the right-hand side of your screen.
PY boost back startup. NY boost back startup.
And there's confirmation of the boost back startup on those two side core boosters. So at this point, both Falcon Heavy side boosters are performing their boost back burns, which is the first of 3 burns each side booster will undergo on the way back to Cape Canaveral Space Force Station. Now, the primary objective of Canaveral Space Force Station. Now, the primary objective of the Canaveral Space Force Station. Now, the primary objective of the boost back burn is to quickly reorient the side boosters onto the required return trajectories, and this is required in the event of a return to a launch site as opposed to a drone ship ocean recovery. And today they're headed towards landing zones 2 and 40 in Florida. Now, meanwhile, in the center core, the 9 M1D engines are continuing to power Falcon Heavy on its nominal trajectory. Now, the engines on that center core are still burning right now. They're set to burn for about another 12 seconds or so, and then they'll throttle down, and we'll have our MECO, our main engine cutoff of that, and then we'll have stage separation of this center core and the second stage shortly thereafter.
PY boost back shutdown. NY boost back shutdown.
MECO. Stage separation confirmed.
And great shot there as the first, main core and second stage separate from one another. And we just heard that call out for second engine startup. And you can see the MVAC engine there on your screen with a beautiful view of Earth behind it.
Bearing separation confirmed.
And we also just heard confirmation of fairing separation. As I said earlier, those fairing halves are no longer needed. And you can see one there on your screen.
And 4 minutes, 38 seconds into the mission, Roman Space Telescope gets its first taste of space. Payload fairings jettisoned.
All vehicles are following nominal trajectories.
And we are coming up on an expected AOS, or acquisition of signal, important step. Really just getting spacecraft's just sending its pulse over the NASA systems.
Yeah, that's right. The acquisition of signal should hopefully be coming up here in a minute or so. That'll be the first opportunity that the spacecraft can go and quote-unquote talk to the ground station, the folks back at Goddard, to make sure that it's still happy and healthy on the way during the stage 2 boost burn. But everything's looking good as far as telemetry is concerned for MVAC. So you can see there the nozzle extension glowing orange as it's going around the Earth.
Launch of the Roman Space Telescope looking very good as the Falcon Heavy carries the observatory into orbit. Of course, the Roman telescope won't really open its eyes, so to speak.
Stage 1 FTS is saved.
Until later in the mission, when it gets out to that Lagrange 2 point about 1 million miles from Earth. Everything that we're seeing, rocket performing exactly as it's supposed to.
PY entry burn startup. NY entry burn startup.
And nominal trajectory so far. Very exciting moment for the spacecraft team.
That's for sure.
PY entry burn shutdown.
Yeah, Steve, so we just had
entry burn shutdown.
We just had the entry burns on those side core boosters as they're making their way back to Earth right now. Now, as mentioned earlier, we will be attempting to recover both side boosters, which are targeting a landing at landing zone 40 and a landing at landing zone 2 at Cape Canaveral Space Force Station. And you can actually follow the vehicle telemetry
PY FTS is saved.
of those side boosters via the telemetry on your screen there.
NY FTS is saved.
PY transonic.
Now, we're just waiting for those landing burns to start up in just about 10 seconds from now.
Stage 2 FTS is saved.
PY landing burn. NY landing burn.
Stage 2 is in terminal guidance.
PY landing leg deploy. NY landing leg deploy. PY landing confirmed. NY landing confirmed.
And we've got a beautiful shot of one of those side core boosters there on your screen. We did, of course, have confirmation of successful landings of both of those side core boosters, and certainly most people in the vicinity heard those sonic booms. Now, coming up next, we are expecting the shutdown of the second stage MVAC engine, and this is known as Second Engine Cutoff 1 or SECO 1. And we should be hearing that call out here shortly, and afterwards we'll just be waiting for confirmation of good orbit.
Nominal orbit insertion.
And there's that call out for nominal orbital insertion after we turn off the MVAC engine on the second stage there. So coming up next, we have a bit of a breather coming up before the next milestone for the mission, SES-2, when the MVAC engine on the second stage restarts as it continues to its orbital destination. So let's hop back over to Megan and Dominic at the Kennedy Space Center in Florida. How did that launch look, guys?
Amazing. Almost didn't make it back here.
Oh.
We went outside to watch it. It was
Express it.
great.
In some ways, I could never believe that this moment would actually happen, and it is here and far more beautiful than I could have anticipated.
Yeah, how
Megan,
does it
I'm
feel?
so glad that we've done this.
Oh, I'm so glad. Thank you so much
you for
what
sharing it
you
with
and the. Oh yeah, no, thank you for sharing it with us. Again, what you guys and the team have developed here is amazing.
We built this in order to provide emotionally impactful and scientifically impactful imagery for all of humanity, and I feel like we have managed to achieve that today.
And now it is up in space. On its way there. Let's actually take another look at that launch, just in case you missed it. It was just 10 minutes ago from here at Kennedy Space Center.
1, ignition, and liftoff. Go Falcon Heavy and go Roman Space Telescope.
Again, NASA is hoping
Vehicle is
this
pitching
mission
downrange.
will help answer some of the biggest mysteries in the universe. And in order to do that, it has to go more than 1 million miles away to a place called Lagrange Point 2, or L2. When could we start seeing data from Roman, Dominic, to start answering some of those ambitious questions you talked about?
Well, Roman is on its way, but 1 million miles is a long distance. It'll take about 3 months for Roman to get out there. We'll be turning it on and commissioning the observatory as a whole so that when we get there, we can begin taking operational observations right away. And those data will start to become available and public around early 2027, and we'll be releasing them every day as we process the data.
I can't
from
wait.
then on.
Can you wait just a couple more months?
We can wait a couple more months because we've got a heavy load of work to turn this instrument on and make it as amazing as it was designed to be.
Absolutely. And so, again, a lot to unpack about this mission. If you have any questions about anything that we're talking about, send them our way by tagging @NASA anywhere where you're watching this broadcast. Okay, Roman is a flagship mission, as we've been saying, for NASA Science. With our Leah Martin now is Nikki Fox, an Associate Administrator for NASA's Science Mission Directorate, and Sean DeMoggle-Goldman, NASA's Astrophysics Division Director.
Hi, Megan. Like you said, I'm joined here by Nikki and Sean, and I have to say I was able to watch your faces right after that mission launch. I don't think I have ever seen two people more excited probably to see a spacecraft lift off. So congratulations, first of all, to the both of you. Extraordinary launch, extraordinary being able to see your reaction.
Thank you. I think you're very kind not saying you saw both of us crying upstairs, but yes.
Incredible moment. So, Nikki, we've talked a lot about the incredible volume of information that this mission is going to be able to give us. How is that going to bring us a little bit closer to answering those profound questions we have in humanity? Are we alone? Are there other universes like this? Are we correct in what we know about our own universe?
Absolutely. I mean, Roman is going to revolutionize the way we look at our universe. It is going to measure dark matter, which is, I know that sounds bizarre, but it's like the fabric of the universe. It's the thing you can't see, but we know it's there. It's going to measure dark energy, which kind of powers the universe. And they have that sort of a cosmic struggle between dark matter that wants to pull things together and dark energy that wants to push things apart. And that will allow us to finally kind of explain our universe and understand our place in it. Not only that, it's going to find a whole ton, tens of thousands of exoplanets, planets that we don't even know are there, billions of galaxies, tens of billions of stars. It's just a spectacular mission.
Oh my goodness, it's so poetic the way you lay it out like that. And Sean, for you, this is just one of many telescopes that we actually have in the NASA fleet. Tell us, how does this work together with the other instruments that we have in space to be able to get a better picture of the universe in which we live?
So thank you. The best way I could describe that is, imagine you're taking pictures of a forest. You want to get pictures of not just the forest and the trees, but the birds on the leaves and on the branches of those trees. We have special telescopes like Hubble and James Webb that zoom in and take pictures of those birds. And we have other telescopes that do the panorama, that get the whole forest. Roman is a superpower because it can do both. It can get the whole forest and then zoom in at the exact same time and count the birds on the branches of those trees. And when you think about it, like once you're doing that, you're doing ecology, except these aren't birds and trees and forests. We're counting up supernova and galaxies so we can study effectively the ecology of the known universe the way that Nikki just described. So it's an amazing thing, and I'm just honestly thankful for just how many human beings put their hands on this thing, not their literal fingerprints, but their hearts and souls went into it, and we're so thankful for all the people that made this happen.
Oh, well, Sean and Nikki, thank you both so much for being here again, and congratulations on a beautiful, beautiful launch.
Thank you. It's such a good day.
Megan, we're going to go back to you.
I am as excited as they are, as well as those folks here right in front of the countdown clock. Again, 14 minutes after launch. Look at them there with their signs, waving, jumping. I love that so much.
Oh, yes.
Again, so much excitement around this launch, again, because it can just discover so much we don't know about our own universe. So again, we've been taking some of your great questions live throughout the show, so we have time for more now. Why don't we pull up the first one on our screen here? What other things will Roman be able to observe besides dark energy, dark matter, and exoplanets?
Oh, Megan, that goes to right what we were just saying about Roman. It has such amazing potential for discovery. One of Roman's surveys will be to look out into our own Milky Way galaxy. Looking at the plane of our galaxy, we can see with Roman's infrared vision all the way to the center of our galaxy and beyond and through and out the other side. That's a part of our own home galaxy that we've never seen in detail before.
Wow.
We will find tens of billions of stars, young stars, old stars, stars all the way across. It'll be the largest astronomical catalog in the history of astronomy.
Wow, I'm actually getting goosebumps. Look at goosebumps as you're talking about it, because again, just to discover so much is so intriguing. All right, let's take another question now.
Yes, what else do we have?
What will the next future telescope be like? Great question.
Well, the Roman coronagraph is designed to test out those new technologies, as we heard about from Dr. Jason Rhodes earlier today. It's a very complex set of new technologies that will block the light of a star so we can see the reflected light of planets orbiting around the star. Roman can see a planet like Jupiter around a star like our sun. The next observatory will have a similar coronagraph that can detect an Earth around a sun-like star.
So smaller and closer. That's really incredible. So for more than 2.5 centuries, America has pushed the boundaries of space exploration, and it continues today with Roman's journey to deep space.
250 years ago, 13 colonies laid the foundation for the greatest and most enduring democracy in the history of the world. One driven by courage, faith, and freedom. From that moment, we became a nation defined not by where we stood, but by how far we were willing to go. We conquered vast frontiers, invented tools that shaped a modern world. We found light in the dark, and we rose from the earth. Faster, higher, farther. We pushed beyond the sky and into the unknown. Today, our curiosity stretches farther than ever. American robots search ancient rivers on Mars. New telescopes unfold to glimpse the first stars. For 250 years, America has carried the light of humanity forward. But American exceptionalism isn't inherited, it's earned. Our greatness comes not only from what we've done, but what we're still determined to discover. Because in every era, across every horizon, America is at its best when it's reaching for something greater. America celebrates 250 years, and we are leading the world into the future.
Now, once operational at L2, Roman will help us study things like dark matter and dark energy. But again, we've been saying they're invisible. So how do you see things like that? Well, Roman will use gravity as a tool, and Dominic's going to explain.
Well, Megan, everything in the universe that has mass has gravity associated with that mass. Gravity bends light, it distorts light, and it therefore distorts images. So when we look out into the universe, past all that dark matter, the gravity of that dark matter distorts the images of the galaxies we see beyond it. And so we can use this as a tool. When we measure the distortions of those galaxies, we can infer the dark matter between us and them. And we can make a three-dimensional map of all of the foam of dark matter that's out there for the first time.
I think I followed you, but you said that there's a visual way to show this.
Let's
for
demonstrate
folks, right? Yes,
this.
thank you. I'm a visual person.
It's a great thing. So since we're going to be ready to celebrate, we have our champagne flutes. The champagne flutes will be our dark matter.
Okay.
They're clear, right? It's invisible.
Invisible.
More or less invisible. And our galaxies will be our iconic Roman Space Telescope logo.
Okay.
Now, the pattern of galaxies is a little like the pattern of letters. It's recognizable. You know what letters should look like. But when dark matter intervenes between us and those letters or those galaxies, as we distort the imagery, you can see the words space telescope are distorted by that dark matter.
I see.
And we can make those maps, and we can then see where the dark matter is distorting the distant galaxies and infer where that dark matter is.
Right.
Just like you could figure out the word space telescope and figure out how much glass is in between the camera and this image.
So again, you might not be able to see the dark matter, the dark energy itself, but because it's distorting things behind it, you're like, something's there.
Yes. Because dark matter moves the light around, just like dark energy moves things around in space. We don't see them directly, but we see their impact on the universe. And since dark matter and dark energy are 95% of the total matter and energy that's out there, they dominate everything. All the stars, all the galaxies, they are there because dark matter and dark energy have pushed them and pulled them to be there. And we would like to understand how those work, because that gets at the very fabric of our universe. How did the universe come to be the way it is?
Sure, really clever. A clever tool that we're using here. Now, Roman's wide field instrument will use this technique along with other methods to explore our universe on an enormous, unprecedented scale. But why does seeing that much of the sky at once matter? Leah is back with her next guest. Hey, Leah.
Good morning, Megan. Nice to see you again. I'm here joined by Ami Toy, who's actually our wide field instrument scientist on the Roman mission. Ami, thank you so much for joining us today. So we just saw Amy and Dominic demonstrating how this wide field instrument actually works, but why do we want to map the sky on this scale? What does it actually tell us?
To understand the universe's biggest questions about dark matter, dark energy, and planets beyond our solar system, we need both the finer details and the really big picture. And imagine photographing a landscape, as Sean just mentioned earlier. Instead of just a single tree here or a mountain peak there, we get the whole picture, and those patterns that are revealed can help us put the whole picture together.
And how is this different from other instruments that we have currently in space? We talked a little bit about the different instruments that are on, but how does that are on Roman? But how does this one actually work differently?
Roman combines Hubble's sharpness, but with 100 times the field of view. And so that means we don't lose the finer details, but we can very efficiently map out the sky, like very large volumes of the sky. And we can also point at a new location with Roman and settle down very quickly. And so we spend more time taking pictures than just waiting.
And so with the speed, we'll actually be able to get some more of that data. We'll be able to get more of it quicker and be able to understand and kind of unravel some of those mysteries a little bit faster.
That's right.
So currently we know of about 6,000 exoplanets, but how many more are you guys anticipating that this wide field instrument will reveal?
We're anticipating around 100,000 new, previously undiscovered exoplanets, including about 1,000 that will be revealed through microlensing, a specific type of gravitational lensing. And so we will learn a lot about cold, rocky planets and potentially some in the habitable zones of their stars.
Really? Okay, so so you're actually looking, is this going to be used in conjunction maybe with the other Habitable Worlds Observatory that we heard Dr. Fox talking about a little bit earlier?
That's right, and it'll help pave the way for habitable worlds.
Fantastic. Ami, thank you so much for joining us today. And Megan and Dominic, we're going to send it back to you.
Thank you so much, guys. Another look at the crowd there. 23 minutes after launch, and they're still so excited to be here as we continue to follow along as the Falcon Heavy's second stage continues its journey out with Roman. So let's head back to SpaceX for that next operational milestone.
Thanks, Megan. Now, just to recap everything that's happened so far, we had an on-time liftoff of Falcon Heavy from historic Launch Complex 39A in Florida at 7:26 a.m. Eastern Time. A few minutes after that, we jettisoned the 2 side cores, with the center core jettisoned shortly after. And those 2 side core boosters performed boostback burns and made their way back to Florida for landings at Landing Zone 2 and Landing Zone 40. And you can see those there on your screen, Landing Zone 40 on the left and Landing Zone 2 on the right. And the second stage performed the first of 2 burns, which lasted about 4.5 minutes. Next major milestone coming up in just under 30 seconds from now will be the second engine light on that MVAC. That burn is set to last for about 2 minutes and will be the second and final burn of those 2 burns needed to send the Roman Space Telescope on its way to the Sun-Earth L2 point. Now, as mentioned earlier, L2 is the Lagrange point on the opposite side of Earth from the Sun, which is approximately 4 times farther from Earth than the Moon. So we should be hearing that call out for SES-2 momentarily. Now, we are, of course, able to monitor the vehicle's telemetry via the graphics that we have at the bottom of your screen there. The engine that is currently firing is, of course, the Merlin vacuum or MVAC engine located on the second stage. Now, this engine has a much larger nozzle than the sea-level M1D engines located at the bottoms of the 3 boosters that made up the first stage. Now, we unfortunately don't have views of that engine burning right now. Now, that extended nozzle allows for optimal performance of this engine when operating in the vacuum of space where there's no atmosphere to burn in. Each M1D engine can produce a max thrust of about 190,000 pounds of force at sea level, whereas this MVAC engine can output about 220,500 pounds of thrust in vacuum. Now, we've still got about 30 seconds left of this MVAC engine burn. Taking a look ahead in the mission, about 5 minutes after the conclusion of this burn, we will then have payload deployment of the Roman Space Telescope, and that deployment is set for the T+31 minute and 31 second mark. And we should be hearing that call out for SECO-2 in just about 10 seconds from now. And just standing by for that call out of SECO-2. On your screen right now, you can see
nominal orbit insertion.
And there we heard that call out for a nominal orbital insertion. And with that, we've still got one more major event coming up, which is the most important one, and that is, of course, payload deployment of the Nancy Grace Roman Space Telescope in just under 5 minutes. How are things looking over at Kennedy, Megan?
Hey, Zach, it's looking really good over here. It's exciting to see that we're nearly there, and we can't wait to see the live images of Roman's deployment into space. Now, we just told you about Roman's Wide Field Instrument, the mission's primary science instrument, but Roman has a second instrument, and that is its coronagraph, a technology demonstration designed and built by NASA Jet Propulsion Laboratory to test how we can block the bright glare of a star to see the much fainter planets orbiting around it. So, Dominic, that could eventually help future telescopes, we were talking about this before, maybe find other planets like or solar system like ours.
Megan, this is an extraordinarily challenging problem. You saw in that little video there the planet being lost in the glare of the light of a star. A planet like Jupiter is 10 million times fainter than the star that it's around.
Wow.
A planet like the Earth is 1/10 billionth as bright as the star. So you have to block that starlight exquisitely. The Roman coronagraph demonstrates all the technologies necessary to do this for the very first time in space.
Wow.
And a future telescope, the Habitable Worlds Observatory, will then carry that forward to measure the light of an Earth-like planet around a sun-like star, look at its atmosphere, and tell us whether there are potentially signs of life on other worlds.
Again, just always advancing what we do here at NASA. I love that.
pushing the boundaries of capability and knowledge
I love that.
every day.
All right, we are now just a few minutes away from Roman separating from the Falcon Heavy second stage. Our broadcast will end shortly after that, but you can keep learning more about this mission here.
Get ready for NASA's new view of the universe and the Nancy Grace Roman Space Telescope with a special limited series of NASA's Curious Universe.
So you're asking for the 10-second description of how the universe entirely works.
We're building one-of-a-kind satellites. It's never been built before. No one's going to build this again.
Want to go deeper? Find the story behind Roman at nasa.gov/podcasts or wherever you get your podcasts.
The idea of pulling back the curtain on so much of the universe that we still don't know yet is super intriguing, not just for scientists, but also artists, too, like singer-songwriter Jewel.
It's Jewel, and as you may know, I make artwork using astrophysical data. And there would be no data more fascinating than dark energy and dark matter. And so it is with this great wish of great success and Godspeed that I wish the Nancy Grace Roman Space Telescope. So exciting.
We're expecting Roman to soon separate from the Falcon Heavy's second stage, so let's watch that moment unfold with Steve and Jared.
Thanks, Megan. We are about a minute and a half away from that expected separation of the Roman Space Telescope from the Falcon Heavy second stage that has gotten it into orbit and on its way to the Lagrange 2 point. Jared, exciting morning so far?
So far, so good. Everything's been right down the middle. As far as stage 2, burn 1 and burn 2 have been perfect, and so really, really great so far. Been a great morning.
And also, we do have confirmation. We did get confirmation from the spacecraft itself early in the launch, around 7 minutes or so. First acquisition of signal or pulse from the spacecraft. That was a big milestone as well. As we look for another 30 seconds. Another 30 seconds before that separation comes. Roman is, of course, recharging its batteries on solar power, and looking forward to that flying free on its own.
Yeah, hopefully we'll get a good shot of stage 2 here. They usually have a great forward-looking camera from the top of the stage 2 to see. There we go. And we have a shot of the Mission Director Center here at KSC on the right. Let's see if we can see.
Nancy Grace Roman Space Telescope, separation
Beautiful.
confirmed.
There we go. Nancy Grace Roman Space Telescope flying free on its way to Lagrange 2 and to open a new eye on the universe. And of course, a lot of celebration with the team, Jared. I know you represent a lot of people in NASA's Launch Services program, and across NASA, a lot of work goes into this. I hope you have enjoyed it. We've enjoyed having you.
Yeah, it's been great. Yeah, wonderful spacecraft deploy. Hear all the claps here behind us in the mission dress and in the mission control room. I'm sure the same at Goddard. Thanks so much for having me today. And most importantly, congratulations to the whole Roman team on behalf of Launch Services program. It's been great working with everybody, and we really can't wait to see all the great science that you're going to do out there.
Yeah, it's going to be terrific. Roman is on its way, and we are going back to Zach at Hawthorne, California, and SpaceX.
Thanks, Steve and Jared, and what a spectacular deployment. Of course, a huge thank you from SpaceX to everyone at NASA for the partnership on this mission, and to all of the teams on both sides who brought NASA's Nancy Grace Roman Space Telescope to the pad and into space. Now, with the launch completed and successful deployment from our second stage, that's going to do it for me here in Hawthorne. So I'll hand it back to the NASA team from here. Over to you, Megan.
Hey, thank you to our launch commentators, and yes, to SpaceX as well as NASA's Launch Services program for getting Roman onto a trajectory towards Lagrange Point 2, or L2. And now the spacecraft teams will take over, so let's hear from Leah with her last guess.
Hi, Megan. I'm actually joined here by Jeremy Perkins, who's part of our science commissioning team. And I have to tell you something funny that just happened. He walked in right after launch and he was showing me on his watch this really interesting pattern of a regular heart rate, then right at 726, this huge spike. So super exciting day for you, super exciting day for your team. We launched just about half an hour ago. Hope your heart rate's starting to settle down just a little bit. So things here are starting to simmer, but it's actually just now picking up for the mission team. What are you guys doing now? What's next on the board?
Yeah, so coming up in the next few hours, I think I just saw the video of us deploying from the rocket, but we contact and then we get our solar panels pointed at the sun so we can make sure we get good power going to the system because we're on internal power right now. Yep, and then over the next day or so, we're going to do a mid-course correction where we make sure we're in the right way to get to L2, about 1 million miles from Earth. And then over the next days, we're going to be deploying our high gain antenna, which is about if you were watching the video just now, you saw it as we were going away from the space vehicle. It's about as round as I am tall.
Oh, wow.
And that's just to get down the amount of data that Ami and other folks talked about earlier, back down to the ground.
And how much data are we talking about?
So we're talking about 1 terabyte of data a day from L2. So the way that I like to think about that is it's like 1 million songs that we're streaming from 1 million miles away every single day for the lifetime of Roman.
Oh my goodness. Now, the team of engineers who are responsible for designing and building the spacecraft are actually watching this unfold right now. What are they looking for?
So like you said, the folks that designed, built, and integrated Roman are actually sitting on console right now and just paying attention to every little detail about Roman. I mean, there's thermal engineers that are looking at all the temperatures. There's folks in making sure the deployments are going okay. There's folks that are making sure the communications are working. And so there's just a whole crew of folks here on campus at Kennedy and up in Greenbelt and all over the country that are actually monitoring Roman as it goes to L2.
And this is kind of their first look because some of this instrumentation actually hasn't even been used or tested since it was first in testing before it was ever even integrated or put into fairings or put on a rocket.
Correct. The last time we've really turned the instruments all the way on was back when we did thermal vac months ago.
Oh my goodness. And so we're going to be going through a period of what's called scientific commissioning, which is kind of that official handover from the engineering team who's doing the checkouts to the science team. Tell us a little bit about timeline and what does that look like?
Yeah, so we're going to be checking out Roman for about a month, and then we're going to be aligning and focusing the telescope, making sure we get all the pointing right, and then we get into science commissioning, like you said, and that's where we're really just checking out the instruments, pointing them at the sky, getting our first starlight on the detectors for the first time, and doing that handover from engineering to science, which is when the science team really starts to get involved in really understanding how the instrument works.
And then we get those images, and we're going to be sharing those with the world. So, Jeremy, thank you so much for being here. Congratulations to your team. And Megan and Dominic, we're going to send it back to you for the last time.
I'm sure that if these folks also had something that Jeremy was wearing to track their heart rate, there would also be a spike around that time. Again, 36 minutes ago when there was launch of Roman right from here at Kennedy Space Center. So, Dominic, I want to take time to take more questions. We had so many of you send in great questions throughout the broadcast, so we have time for a few more. Let's take the first one.
Absolutely. What do we have?
How would repairs or refueling Roman work given the distance of the telescope from Earth?
It's a great question. We did design Roman to be at least refuelable so that its fuel ports are accessible. A sufficiently advanced robotic refueling spacecraft could get out there to 1 million miles away, could rendezvous and dock with Roman, grapple with it, and add more fuel. That could extend its lifetime to give it even more time to map the cosmos.
But is that the plan, to refuel it? Hopefully not.
We don't have a plan to do that, but we designed it in so that it could be possible. We didn't want to preclude the possibility of extending the lifetime, but it relies on servicing capabilities that are still in development.
Yeah, I said hopefully not because it's perfect. You made a perfect
It is perfect, but we want even more of the perfect.
All right, let's take another question now. Let's see. Oh my God, what light spectra does Roman operate with? So sorry, guys, terrible vision I have.
That's fine. So the Hubble Space Telescope was designed primarily for ultraviolet and visible light. It extends a little bit into the infrared. The James Webb Space Telescope is designed to focus on the infrared and out into longer wavelengths. Roman bridges that gap. It is sensitive to light in the near in the visible range, and say orange light, but it goes further out into the infrared than Hubble can. And with that infrared vision, it penetrates through clouds of gas and dust and sees farther into our galaxy or into star-forming regions than has been possible with visible light.
Wow. Okay. Well, and again, remember, we did ask some folks to vote on Twitch about what
Yes, we
they'd be
did.
most excited to study. Roman would be most excited to study. So let's pull up you guys' answers now. Again, it was dark energy, dark matter, planetary systems. Oh, that is not surprising there. Dark energy
Yes.
and dark matter, Dominic.
That is what we built the mission to do, among other things, and it's part of the key questions about the universe, the fabric of space and time, that Roman will unlock for us.
Yeah. Again, there's just so much we don't know about it. So, of course, there must be so much curiosity around it.
There is so much out there to discover. We do not understand a lot about the universe, and Roman was designed to give us the data we need to answer countless questions.
Got it. And then another quick note, don't forget about Roman's Adopt a Pixel campaign. We debuted it earlier in this broadcast. A single Roman image will have 300 million pixels, and we are inviting you to sign up for one of those pixels by visiting nasa.gov/adopt a pixel. Again, how cool is that? Your own cosmic dot in the universe. I hope you're going to sign up.
Oh, absolutely, Megan. I don't know what my pixel will contain. Will it be a star? Will it be a galaxy? Will that star explode? Who knows?
Yeah, will the star
Which one
explode?
will
Yeah,
you
that
adopt?
would be great. I would love anything. I mean, I just think it's so great to call, to be able to call some part of this beautiful images that we're going to see my own. So that's a really fun campaign.
Yes.
Thank you to those who developed it. All right, so that's going to do it for us here at Kennedy Space Center of this live coverage of NASA's Nancy Grace Roman Space Telescope mission. A huge congratulations to everyone involved, and a big thank you to everyone who participated in our broadcast. Of course, especially to you, Dominic. It was so great having Dominic, it was so great having you.
It was thrilling to be here with you, Megan. I couldn't have had a better partner to go through this launch with. It has been an amazing day. Roman had a beautiful, picture-perfect launch. It's going out on its way to space, where it's going to do fabulous, fantastic things.
And we just want to give a shout out again to the teams over at Goddard. We had our launch support room over there, specifically supporting launch operations. And then we also had the mission operations room. Oh, they're waving now. Congratulations to you all.
Yes, we can see the launch support room on the right and the mission operations room on the left. Those people are hard at work preparing the observatory. In fact, it's already operating. And over the next several months, we will have a hotbed of activity, especially in the mission operations room that you see there. I'll be sitting in there some of the time as we get the first data back and tune up this observatory to do spectacular, world-changing things.
And I just got word that the spacecraft is power positive. Can you tell us about that?
Yes. So that means that the solar arrays are actively providing electricity. It's no longer running off of its internal batteries. In fact, hopefully it'll be recharging them at this point. That's necessary because we need all of that electrical power to keep the observatory running smoothly.
Oh my gosh, that's so exciting. Oh, again, I'm getting goosebumps. It's so cool to see what we can accomplish together and what NASA continues to do to advance what we do in air and space. So we invite you now to our post-launch news conference. That will take place at 9:30 a.m. Eastern Time on NASA's YouTube and X accounts. We will have NASA leadership and Roman scientists on to answer any of your questions. And remember, launch might be over, but the mission has just begun, as we've been just telling you about. That team of people at Goddard continuing to follow along with the mission. And you can continue to follow along with us on this groundbreaking journey by going to nasa.gov/Roman. You're definitely going to want to check out our live broadcast when we will reveal Roman's first images. We're aiming for early 2027, Dominic.
Those first images will be iconic in the same way first images from Hubble and Webb have permeated the nations and the world's consciousness. Roman is going to do that on an unprecedented scale.
Yeah, let's discover new things we don't yet know about our universe. Until then, have a great day and go Nancy Grace Roman Space Telescope.
Go Roman.
T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon Heavy and go Roman Space Telescope.
Vehicle is pitching downrange. All M1D chamber pressures are nominal.